Alright, detection of anions. Like we have said when we're trying to identify cations. Anions, we also have reagents for anions. These are silver nitrates. There's a question that's common under this silver nitrate. Silver nitrate must be stored inside brown bottle, or we call it amber bottle. Amber bottle. Why? This is because this amber bottle prevents lights, white lights, from entering the bottle. Otherwise, if the light enters the bottle, it will what? It will decompose the silver nitrate. So we must use amber bottle so as to avoid the decomposition of silver nitrate when it comes in presence, or when it comes in contact with what? With light. So silver nitrate, we use it for the following anions: carbonates, sulfides, sulfide, chloride, bromide, and iodide. You can use silver nitrate to test for 1, 2, 3, 4 on any of these 6 anions. When we get there, I'm going to quickly explain it. These ones are white precipitate, white precipitate, white precipitate. This is reddish brown, and this is violet. So when we come there, when we get there, we are going to explain it. Then we have barium nitrate or barium chloride. That is another precipitating agent for anions. We can use it for any of the listed above, excluding the halogens and including sulfates. We can use it to identify any of the anions that silver nitrate can identify, excluding what? Halogens, and including what? Including sulfates. Ditto for lead eternate. Lead eternate is another reagent that we can actually use to identify any of these anions, any of the 2 anions without repetition of one. Any of these anions that these 2 reagents can identify. Magnesium sulfate can only tell us about the presence of CO3 2-, and potassium permanganate or potassium tetraoxomanganate 7, as far as the isopath name is concerned, can be used to detect the presence of these anions. So, ladies and gentlemen, in a nutshell, you must know how to use this reagent to identify the presence of the following anions, of the above listed or above mentioned anions. Now, it's not only in organic substances that we can use qualitative analysis to detect. We can also use qualitative analysis to detect what type of organic compound, and that is why they said that it is used to detect, to identify unknown substance. So we can also use it to identify unknown organic compounds, and that's the test I want to quickly do right away. And in fact, what I'm going to do right away is the iodoform test. What I'm going to do right away is the iodoform test. Iodoform test is basically used to detect compounds, organic compounds that have organic compounds, particularly alcohol that have hydrogen and an alpha methyl group. This can be any group. So iodoform test is used to detect, is a test that we can use to test for what? Test for organic compounds like carbonic compounds, like what? Like alcohol that have what? That the carbon carrying the OH has hydrogen and an alkyl group. Do we understand? What that means is that we can use what we call iodoform test to detect the presence of ethanol. Ethanol is C2H5, so CH2OH. If you look at this is the structure H, CH3, and we have OH, then we have H. This R can be anything. This group here can be anything. So far the compound or the carbon carrying the OH group has 1 hydrogen and 1 methyl group. Ditto, which means we can also use it to detect the presence of what? Of a secondary alkanol. If you look at this HOH, a methyl group, CH3. And we're on the same page. So this can be anything. In case it is CH3 now, or in case it is CH3 now. So which means we can, and this is called what? This is called 1, 2, 3, propan 2 or propan 2-or. So it simply means you can use it to detect the presence of propan 2-or. So let's check actually if it is true. This is methylated spirit. Methylated spirit. I'm going to put my methylated spirit. If it's going to be a positive test, if it's going to be a positive test, it's telling me that it's a positive test, I must see a pale yellow at the end of the reaction. After adding 10% iodine solution and then adding sodium hydroxide, the reddish brown or something of this nature, or the what, or the violet color must change to yellow if it is actually a compound that can be detected with iodoform test. So I'm going to put my iodine. Good. Then I'm going to add my sodium hydroxide. Wow. This is a negative test. As you can see, it is completely decolorized. It is completely decolorized. It is a negative test. It is telling me that the compound does not have a carbon, that compound is not a compound, that the carbon carrying the OH or the carbonic carbon does not have an alky, an alpha alky. So this is a negative test. If it's going to be a positive test, then I must have what? I must have a yellow, a pale yellow precipitate. Alright. I can equally try to test for propan 2-or. This is propan 2-or. And I'm going to add my 10% iodine solution. Like you can see, this is what I have. Then I'm going to add about equal amount of sodium hydroxide. If it's going to be a negative test, then it must be colorless. It must be colorless. Let's wait and look at it. Of course, this is not colorless, other than that the lightning coming in. So then, of course, we can also use acetone. Acetone. Check if acetone. This acetone is actually it's actually a ketone member. It's actually a ketone member. In fact, it is the first member of the what? Of the ketone group family. And we had our sodium. As you can see, it's completely colorless. Completely colorless. Then we can add our acetic acid. I think I've not added the acetic acid. And this is my 10% iodine solution. And I'm going to add my sodium. As you can see, it is still colorful. It is not colorless. So it is telling us the presence of what? Of a compound that has a compound like secondary alcohol or an acetic acid, or a carbonic compound, a compound containing carbonic carbon and alpha methyl group. Take a look at the structure of acetic acid. CH3 C double bond O OH. So this is alpha methyl group. So it is yellow in nature. In fact, ladies and gentlemen, this is simply telling us, this is propan 2-or. This is propan 2-or, which is what? CH3 CH OH CH3, propan 2-or. So in a nutshell, of all the solutions, of all the reagents, you can see that it is only propan 2-or and acetic acid. It is only propan 2-or. Like you can see this and this, they are different. They are different. It is because of the light that we may not able to see the yellow color of this. It is only these two reagents that will not give colorless. In a nutshell, iodoform test is used to detect presence of secondary alkanol. Is used to detect the presence of secondary alkanol like propan 2-or, and it's going to give you a pale yellow precipitate. A pale yellow precipitate. Meanwhile, apart from that, you can also use acidified potassium heptaoxodichromate 6 to confirm the presence of what? Of propan-2-ol. And it's going to reduce propan-2-ol from, it's going to reduce acidified potassium heptaoxodichromate 6 from chromate 6 to chromium 3 ion, from chromium 6 ion to chromium 3 ion. So in a nutshell, what this simply means is that we may be able to test for the presence of what? Organic compound. And at the same time, even if you don't know what the substance is, so far it is having an antiseptic odor, or it is giving you an odor that is similar to what you see, that is similar to the odor of spirits, then it is likely to be what? Propan-2-ol. With limited time and space, I think we have been able to justify how we can test for the presence, and we have been able to identify what iodoform test is all about. And then before we round it up, I want to quickly inform each and every viewers that please, if you enjoy this video, please press the like button, subscribe, and share to fellow candidates. Thank you for listening.